This is a new topic, chapter 1, relations and functions. This is related to the chapter relations of class 11. Class 11, we had a chapter. This is a bit difficult chapter. Class 11 also many of you had problem in this chapter, relations and functions. It's a continuation. So today I am not going to do any sums. I'll be explaining today. Harsh, just mute the audio. Thank you. Please complete your writing and let me know so that I need to explain. Is it done?
Done.
Okay. Those who joined late, Manasi, Jansi joined late. Is it over, Mansi?
Yes, ma'am.
Okay, Jansi is there with you, na?
Yes, ma'am.
Okay. Let me start with the explanation. Shall I erase? Shall I erase this?
Ma'am, last line.
Okay. Last, I do it first. Give me a green signal, the one who said in the last line.
Done, ma'am.
Okay, that is because I need to explain a bit here. Okay. Now, don't write now what I want to explain. If you want to write, you can write. Just an explanation here. Recapitulation, Cartesian product, class 11, you people have done. I'm going to take itself, Cartesian product. This is an explanation. This is an explanation. If you want to write, you can write. Suppose I take a set 1, 2, 3. I want to explain what is relation. So before I go to the definition, I'm just taking an example here. Now, when we do Cartesian product, we take two sets. One is A, the other one is B. But here we are taking the same set. We are not taking a different set A, we are taking the same set. So we are trying to find out a relation between the elements of A. I have taken 1, 2, 3. Here also 1, 2, 3. I am trying to find out a relation from set A to set A, to itself, not to a different set. Now, if I write A cross A, Cartesian product, class 11, you all know how to find out the Cartesian product. Okay, how to find out the Cartesian product, the ordered pairs? Let us do that. 1, 1. I hope you remember. 1, 2, 1, 3. The ordered pairs I am writing. Then beginning with 2, 2, 1, 2, 2, 2, 3. Then beginning with 3, 3, 1, 3, 2, and finally T3. If you want, you can write the explanation. Later on, when you go through it, you can understand. Wait, let me admit a few more persons. Moina, Rudra. They are waiting in the queue. Okay. So this is A cross A. A cross B, instead of A cross B, we are taking the same set, A cross A. Now, I choose a few ordered pairs from this A cross A. I name it as R1, a set R1. Suppose I choose 1, 1, that's 2, 3, 3, 2, and one more, say suppose 2, 2. Okay. So what do I observe? That this set R1, today I am giving explanation of tree. This is very difficult topic. So R1, what do I observe? R1 is a subset of A cross A. I observe that R1 is a subset of A cross A. Now what is subset? Just a recapitulation. Subset means what? Every element or every ordered pair which is present in R1 must also be present in A cross A. So I see that R1, all the ordered pairs of R1 are from A cross A. They are contained in A cross A. Hence, I can say that R1 is a subset of A cross A, Cartesian product. Now, in other words, what can I say? Instead of saying R1 is a subset of A cross A, if I want to write in words, I shall be saying R1 is a relation. R1 is a relation from A to A. I shall be saying R1 is a relation from A to A. Now, next step. Instead of saying from A to A, I can make it more shorter. I can say R1 is a relation in A. In A. In A. When I say in A, it means from A, from set A to set A. It's a relation. Okay. Now suppose another set R2. I take another set R2. And I'm taking a few ordered pairs. Say suppose 2, 2, 2, 4, and one more I take, say 3, 2. Look at the set R2. Set R2. I have taken 3 ordered pairs. Let me again compare this R2 with A cross A. 2, 2, yes, 2, 2 is present in R2. It is also there in A cross A. 2, 4, 2, 4, it is there in R2, but I don't find 2, 4 in A cross A. It is not there, cross. It is not there in A cross A. 3, 2, yes, 3, 2 is available in A cross A. So, my conclusion for this set R2, will be R2 is not a subset. I cancel it. Not a subset of A cross A. R2 is not a subset of A cross A. So, in other words, what am I going to say? If I want to conclude, I'm going to say that R2 is not a relation. Not a relation in A. In A. That means from A to A. Okay. So in order to be a relation, what do we learn? I just mark these two sets. In order to be a relation, what do I observe? This set R1 or R, whatever you name it, needs to be a subset of A cross A. It has to be a subset of A cross A. Now, please go back to the definition, what you have written now. First line, go through the copy, what you have written. Let A be a non-empty set. Yes, look, I have taken a non-empty set. And let R be a subset of A cross A. So here I have taken R1. Let me change it to R. Here I have named it R1. So here I got a set R. I got a set R, which is a subset of A cross A. Hence, R will be termed as, or is called a relation in A. In A means from set A to set A. Next step, what is written in your copy? Check. If ordered pair A comma B belongs to R, we say that A is related to B. And how do we write? A capital R B. Now same thing here also. Look here. Look in set R. I have changed it from R1 to R. Look in set R. Look here on the whiteboard. Sorry. Okay. Look in the set R. What do we observe? 3, 2. Here I am writing. 3, 2 belongs to R. 3, 2 belongs to R. So that means 3, 2 is related to A cross A. It is a related from A to A. So how will I write in short? 3 R 2. That means 3 is related to 2. 2 comma 2. It means 2 R 2. That means 2 is related to 2. This is what is written in your copy. If A comma B does not belong to R, then A is not related to B. So same example. I refer to set R. If I say 3 comma 4, I check that in my example, 3 comma 4 does not belong to R. I don't have an ordered pair. 3 comma 4 which is available in R. It's not available. So in short, I'll write 3 is not related to 4. Cancel R. 3 is not related to 4. So the summary is in order to be a relation, it has to be a subset of A cross A. Look at the example that you have written. Please refer to the example that you have written. In your copy, A is a set containing elements 1, 2, 3, 4, 5, 6. And R is a relation given by ordered pair AB such that A minus B equals to 2. So difference of two elements. The answer is 2. So R contains 3, 1. First ordered pair 3, 1. Yes, 3 minus 1 is 2. The second ordered pair 4, 2. I have to choose from A. From set A. I cannot take elements outside set A. 4, 2. Second ordered pair. Yes, 4 minus 2 is equal to 2. Third ordered pair 5, 3. 5 minus 3 equals to 2. Fourth ordered pair 6, 4. Yes, 6 minus 4 is giving me the difference 2. So clearly 3 are 1. That means 3 is related to 1. First ordered pair. 4 are 2. 4 is related to 2. But 1 does not, see is related there. 1 is not related to 3. I don't have any ordered pair 1 comma 3. Because 1 minus 3 will give me minus 2. So 1 is not related to 3. Rather 3 is related to 1. This next one, 2 is not related to cancel. R cancel. 2 is not related to 4. Yes, it's not related to 4 because as per the question, 2 minus 4 will not give me 2. It will give me minus 2. Okay, so that's all about relation. So in order to be a relation, what is mandatory? It has to be a subset of A cross A. Any doubt, any clarification you need, then I'll move to the next topic. Please ask. Anyone has a question, you can unmute and you can ask me. Or else I'll go to the next subtopic, domain and range. Is the term relation clear? In order to be a relation, I repeat, it has to be subset of A cross A. Shall I move to the next subtopic?
Yes, ma'am.
Yes.
Yeah.
Right first, I'll explain then. Domain and range of a relation. Write this first. I'll explain it. Let R be a relation in a set A. Full stop. Then the set of all first coordinates. Then the set of all first coordinates of elements of R is called the domain of R, written as dom within bracket R. If it's done, you tell me.
Done, ma'am.
Done, ma'am.
Okay. Then I'll just remove this. Continue. Okay, continue. And the set of all, is it visible? Yeah. And the set of all second coordinates of R is called the range of R. Comma, written as range within bracket R, capital letter R. I'll give an example, then I'll explain. Example. Let capital A equals to curly bracket open. Inside the curly bracket, take a set 1, 2, 3, 4. If dot dot up to 16. No need to write all. Give dot dot up to 16. And let R be a relation. Be a relation in A. When I say relation in A, it means relation from set A to set A. Given by capital R equals to curly bracket open. Ordered pair AB such that, such that B equals to A square. B equals to A square. Close the curly bracket. Then, next step, R equals to. Now look here. Have you all written? I'll explain here. What is the rule here? What is the rule? R is what? Those ordered pairs where B equal to A square. Now from set A, find out. 1 can be written as 1 equal to 1 square. 1 equal to 1 square. So my first ordered pair will be 1, 1. Next, 4 equal to 2 square. From this list, from this set A, 4 equal to 2 square. That means my second ordered pair will be 2, 4, not 4, 2. Because when I compare with B equals to A square, 4 is B, A is 2. What else? 9 equals to 3 square. So if I compare it with B equals to A square, so B is 9, A is 3. So 3, 9. Next ordered pair, 4, 16. I cannot further continue because set A has up to 16 elements. I need to stop. So this is set R. Now, the definition of domain, please, I have erased it. You refer to the definition, what you have written. Domain. The set of all, what have you written there? The set of all first coordinates. This you have done in 11 also. So dom R will be the first coordinates. From every ordered pair, take the first component. So 1, 2, 3, 4. This will be domain of R. Set of all first components or first coordinates. Next is range of R. Refer to the definition, what you have written. Set of all second coordinates of R. That is second components. Which are the second components in R? In our example, 1, 4, 9, 16. 9, 16. So this is what is domain and range of a relation. Any clarification, any doubt you have, you can ask. I'm going a bit slow today, only explanation. So many things to explain before I start with exercise. So today and tomorrow I'll explain. It's done?
Yes, ma'am.
Okay. If it's done, please give the next topic, which is new for you people, types of relation. New topic, types of relation. Give the topic, types of relation. Can I remove this? I want to hear from Larry. Larry is there. Unmute and say, Larry, can you hear me, Larry?
Yes, ma'am.
Done.
Yes, ma'am.
So the next topic, types of relation. Let me adjust. Yeah. Types of relation. Concept explanation, I'll go a bit slow. Concept explanation. Types of relation. Number 1, empty relation. These are new terms for you people. Empty relation. First you write, then I'll explain it. Write down. A relation R, capital R. A relation R in a set A. In a set A is called an empty relation. Is called an empty relation. Some people also say void relation, VOID, is called an empty relation, comma, if no element of A is related to any element of A. Any element of A. Full stop. And oh, sorry, full stop. Now you have written you have given full stop. Okay, stop there. Next step. R equals to capital R. R equals to 5. See here, it's given no element of A. That means 5. R equals to 5, which is a subset of A cross A. You people know, null set is a subset of every set. So R equals to 5, which is a subset of A cross A, is the empty relation. 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 I'll give an example also here to explain this. Please write an example. For example, write down. Write an example here. For example, let capital A equals to, within curly bracket, 1, 2, 3. So this is a set containing 1, 2, 3. And capital R equals to ordered pair A, B such that, I'll give an equation here. A plus B equals to 8. 8. 6, 7, 8. 8. Then, no element of capital letter A, set A, is related to any element of A. So, next line. So, comma, R is an empty relation. I'll explain this. First you write. R is an empty relation. Full stop. That's all. I'll explain now. This is the example. See, what is the example I've taken? 1, 2, 3. 3 elements in set A. But in set R, the equation is A plus B equals to 8. Now tell me, from set A, can I take any 2 elements, sum of 2 elements? Will it give me 8? 1, 2, 3. 1 plus 2 is giving me 3. 2 plus 3 is giving me 5. So, what do I conclude? There are no elements in set A. There are no elements in set A which is going to satisfy this equation. So, no element of set A is related to set A itself. Suppose here, I'm drawing also. See, I'm drawing also set A. Both are set A. Error diagram I'll draw. 1, 2, 3. Here also I have 1, 2, 3. So I cannot relate 2 to 3. No, not possible. Not possible. Cross. Because 2 plus 3 is giving me 5. It's not giving me 8. So what do I find? That there is no element of first set A which can be related to the second set A under the condition A plus B equals to 8. So what type of relation is this R? R will be called as an empty relation. 5. R is coming out to be 5. Null set. I don't have any ordered pairs. I don't have any elements from set A which fulfills this criteria. Okay. So this is point number 1. First type of relation, empty relation. Next, Point number 2. Write down point number 2. The next name. Wait, let me erase this. Today my daughter is not there to help me out. Point number 2. Write down universal relation. Universal relation. Universal relation. Point number 2. Universal relation. Where is the other one? Universal relation. Now write. Under this point, please write. A relation R. A relation R on a set A is called universal relation. Is called universal relation. I'm just writing UR so that you all can understand universal relation. Comma, if each element of A, capital letter A, is related to every element of A, is related to every element of A. Element of A. Full stop. Thus, R equals to A cross A is the universal relation. Is the universal relation. I've just written you one. I'll give you an example also. For example, let capital A equals to curly bracket open 1, 2, 3. Again, same set 1, 2, 3. And capital R equals to inside the curly bracket A comma B ordered pair such that A plus B less than equal to 6. I'll just adjust here. A plus B less than equal to 6. Then what do we observe? Then what will be R? Sum of two elements is less than or equal to 6. Yes, if you check set A, 1 plus 1, it will be 2, which is less than 6. Then the next ordered pair will be 1, 2. Yes, it is also less than 6. Sum. Then 1, 3. Yes, this is also less than 6. Then 2, 1. It will be less than 6. Summation. 2, 2. 2, 3. 2 plus 3 is 5. Less than 6. Then 3, 1. Less than 6. 3, 2. Sum is less than 6. 3, 3. Sum is equal to 6. In the statement it's mentioned A plus B can be less than or equal to 6. So this is set R in the roster form. Roster form. You remember roster form, no? Now, if I look at the set R, this is nothing, but this is what? A cross A. This is A cross A. It is same as the Cartesian product A cross A. So, R will be called as the universal relation, UR. In the definition, universal relation is mentioned. Each element of A is related to every element of A. That means 1 is related to 1, 1 is related to 2, 1 is related to 3. Every element related to every element. So this is what is meant by universal relation. Done? Any doubt? Two types of relations I have explained. Empty relation and universal relation. Anyone has a question?
No, ma'am.
The third time, I'm not going to start today. It's 12:39. Tomorrow I'll continue. Just write the name and leave. We will stop now. Write the name. Point number 3. Identity relation. And we will stop today. Identity relation. I'll explain it tomorrow. I'll continue with the explanation tomorrow. Thank you. No assignment. You continue with the miscellaneous exercise. Everyone has to submit.
Thank you, ma'am.
Okay, so let us stop today. Tomorrow I'll continue with the explanation. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank
you,
you,
ma'am.
ma'am.
Read it before you come tomorrow. Now please go through it.
Okay, ma'am.